Good morning, everyone. Quickly send your attendance. Everyone, please send your attendance. I think everyone has sent the attendance. No, 39 members have sent. Still another 9 members. Okay, we'll start the class. See, in the previous class, we are discussing some of the example. See, one precondition about this chapter when you study process control is, in the previous class I have shown the outputs of the programs. If you clearly understand that, then only you can understand this chapter, the topics, the examples which are there in the textbook. That is the precondition. Make sure everyone please try to understand see the previous video on the program, on the fork examples. If it is completely understood, then if you whenever you see the examples in the textbook, you can understand. Without that logic, straightforward, if you see as it is, if you see the textbook, you will not, I assume that it will not completely be clear why the flow is like that, which process is going to execute first, which is a child, which is a parent, what is the idea of the child and parent. All those things it will be not clear. Next, the next topic that we are going to start is race condition. The next topic we are going to start is the race condition. Uh, See, what is the situation occurs is, as you all know, when the fork is being used in the program, the fork creates one process, child process. The order of process execution is not known to anyone because it is based upon the scheduling algorithm in the operating system. It can be any scheduling algorithm, whether it can be the child process may execute first, it will complete its job, or the parent process may complete its job. It is left to the scheduling algorithm. Because of the order of execution, the process runs, the final output is going to change. Final output is going to change. Therefore, the final output is changed, then it is called as a race condition. These race conditions will occur when multiple processes are trying to do the same thing with the shared data. With shared data, if they are doing its different data, it is not a problem. Child is doing some other operation, uh, child is doing some addition operation, and parent is doing some multiplication operation, and they have not shared any data. In that case, the order can be anything. There is no situation of race condition. But the result of the addition, if it is dependent on the result output from the division operation, in that case, the child process should execute first. It has to give its output to the parent process. Then that output will be taken and some addition operation will be done. If that is the case, if that is the case, In that situation, what happens is the order is important because the data has been shared between processes. Then this race condition occurs. Then what we should do in order to stop this problem, the race condition problem? We'll see with an example, then it will be clearly understood. This example we have seen previously. See, there is a if condition. In that fork, we are going to create a process. If it is less than 0 means if the fork function returns less than 0, it indicates it has not created uh, the this one. Which one? The child process itself, there is a problem. Next, if it is a successful execution, then it will not go to if condition, it will come to else. In the else, if PID equals 0, it indicates child process is going to execute this block. If the parent process comes, the PID will not be 0. The PID will be some number. The parent process, if it executes, it will not come inside the block. See, all these things what I am saying, you can understand if you see only the video of the previous class, because there you have I have explained why it will come inside the PID, why the PID will be 0, all those things. Now, PID equals 0, it indicates the child is executing this block. See, inside this else, what is there? There is one more process we are going to create, fork. Then that we are going to call it as a second child. This is the first child. This is a second child. The parent of the second child is first child because you are going to create inside the PID equals 0. When the child is executing this block, you have created the fork, means the parent of the fork will be the first child. Okay, if it is less than 0, error. If it is greater than 0, it indicates the first child, which is also called as parent from the second child, you are calling the exit function. You are calling the exit function. If it is not the situation, sleep the child, sleep for 2 seconds, child, sleep for 2 seconds. After that, you print this statement. After that, you print for this statement, second child, parent ID, exit. There is one exit function. See how it is going to happen. There are two scenarios. One is parent process is going to create, it is going to execute. Then the next, assume that second is the child process will execute. It will not come inside the if, it will come to else. It will come inside. Once again, the fork is fork will be done. Then one more child will be created. Once again, this entire block will be executed now. When it comes inside this, if the PID, if it is greater than 0, means the parent from the second fork, which is also called first child, if it exits, see, if it is a parent, we are calling exit function. What it indicates? Forcibly, you are going to terminate the process. Second child parent, you are going to terminate. Then, who is the parent of the second child? Before the completion of the child, if the parent dies, then init process, there is a init process which is running in the background. The ID of that will be process ID, PID will be 1. PID will be 1. That init process, it will become a parent process. If the parent is not there for the child, it is called as orphan process. For orphan process, who is the parent? Init process is the parent. If the parent process executes first, it will terminate. Then, if you print this statement, second child parent ID, that will become 1. Because what will be the parent ID? 1 indicates init process is the parent ID. If child process exits first. If the child process exits first, after that, the parent process, if it exits, then here it will print second child, the parent ID. That is, the parent ID is the first child ID because that is the parent. See, this is the order. If the child dies first before the second parent, you will see the output like this. Second child, parent ID equals 1. It indicates for second child, parent is init function. The ID of the init process is 1. Or else, if the parent has not died because of this exit function, then it will be some number greater than 1. This is the problem. If the order change, the parent or some other logic, everything is going to change. In order to avoid that, there is one more example. In order to avoid that, we have an alternative. What we'll do is we'll make the get PID. See here, you have to add this loop. While get PPID not equal to 1, sleep. If you add in indefinite time until the parent PID, if it is not equal to 1, the meaning if you sleep, what is this? This is indefinite time until the parent dies. Not equal to 1 means some parent process is executing. Parent process, what it will do is, it will sleep for longer time until the child completes. Until the child completes, while get PPID not equal to 1 means the parent ID will be present, that will be some number 1, 2, 3 like that. Then it will sleep for every 1 second. During this time, what happens? The child will complete its execution. After that, get PPID will become 1 because this one will become, the parent process is going to execute. Parent process going to execute means that the parent ID will become 1 init process, then it will come out. Indefinite times, if you use this while loop, then simply it is going to use the CPU time. That is why this is not the option, adding this while loop. Simply looping. For that, what we'll do is we are going to write some macros or the functions. We'll write these macros for the functions, right? Tell parent, wait parent. Tell child, wait child. If you include this inside the program, then you can inform the parent, or you can inform the child that I'm completed or I'm going to wait for the parent or the child. See, like this, tell parent of get PPID, if you give the function to this, it will inform the parent process that we are done, I have completed the execution. Wait parent function, this is already been inbuilt. The logic you have to write that wait parent, it will wait for the parent to complete his execution. In the same way, tell child, if you pass the ID to this, tell child that this execution is complete. This wait child means wait for the child to complete its execution. You are informing based on these actions, you can write the logic. These are the functions, or these are called as macros. If you use these functions or the macros, then you can control the execution of the multiple process. You can make the parent to wait. You can make parent to wait until the child is completes its execution. By informing that, tell parent that, or wait parent you can use, wait for the parent. Or you can inform that child, tell child we are done. The parent will inform. The parent will inform that parent process will execute these two. Tell child and wait child. Based on this, you can take the actions. These are called as functions or the macros. If you use, you can solve race condition. This is a problem. This is a problem and this is a solution with this function and macros. The next thing is, many a times I have used the word called execute. Till now we have seen fork, wait, wait one, wait three, wait four function. Now there is a new function called execute. EXEC, execute function. This is also an important function. In the lifetime of the process, this is an important function, execute, and from the in that test or in the exam also it is important, this execute function. What this execute function will do is, now the process is being created. That process, the caller process, if it use this function execute, it will replace the calling process by the new program. Calling process by a new program. A calling process, assume that it is executing. There are 10 statements. In that, the fifth statement is execute. Execute function is there. The caller process now, whenever it sees the execute function, in the argument, there will be a path to the new program. The address will be there of the new program. Now the execute function will go to that program and it will execute. What all the informations are going to change? See, since this is a new program or a new process, whether all the information gets changed? No. One process is being executed means so much of information, data structure will be there with that. Therefore, execute function, what it will do is, it will replace the calling process by a new one. But what you have to remember is, the execute function, it will not create a new process. It is not creating a new process. It is executing the other process. No new program is created, just replaces the current process with a new program. If you check the ID, the process ID will be same, even though it is executing other program. If you check the ID, it is same, the old process ID. These three things you have to remember. Same process ID, no new programs are created. It is going to replace the calling process by a new process, new program. How many options are there? Execute L, it is not one, execute L, execute V. Here L means list, V means vector. Remember, execute L, execute V. L means list, V means vector. Another function, LE, list effective ID, V effective ID. This is another execute LP, VP. There are 6 functions are there. There are 6 functions. In this 6 function, 4 are almost same, the other 2 are different. See, if you see the argument, then you will understand. Path name, path name, path name, path name. 4 times. In 4 functions, you have seen the path name. For last two, LP and VP, it is file name. What is the meaning of that is, first 4 function execute functions, in the argument, there will be a path, the address, the complete address where that new program is there. But what about the last one, last 2 functions, LP and VP? It is the file names. Directly you will give the file names. Then where it is going to search? It is going to search in the default address. Where does the default address you are going to get? One option will be environment variable. In the environment variable, there is a path variable. In the path, it is going to parse and it will get the location, or else the current directory. In the current directory, which program will be there? That program is going to execute. It is very simple. Absolute, you can understand like this. This is an absolute address. This is a relative address. Relative address means just we'll give the file names. Absolute address means we are going to give the full address from C drive colon some program files inside that, another address, complete path. That is the main difference between these first four and the last two. The next difference is, see what is this L and V is list. List means the argument what you are going to pass, that complete argument list, it will be there as you are going to send it as a parameter. If you are sending 5 values, then path name, argument 0, argument 1, argument 2, argument 3, argument 4. 5 values you are going to pass it as a list, as a parameter, arguments itself. But in case of this V vector, all those arguments, it will be in the array. The list of arguments that will be in the array, that pointers that you are going to send, the pointers, the array of pointers to that arguments that you are going to pass. Is it clear? The main difference between this L and V is this one. All the arguments it will be as the argument. It will be as a parameters in the you are going to send these values argument 1, 2, 3, 5, 4, 5. But here in the array you are going to send. That is the main difference. What about this E is based on this, you are going to send the arguments as a list itself, but with that you are going to send this E. E indicates environment variables list, an array of environment variables. We have seen this environment list in the previous classes. That environment list, that is required to the new program, because execute function, it is go and execute the other program, right? To that new program, the environment list is required. In order to send it to that new program, we are sending the environment list as an argument. In the same way, for VE also, the third argument will be the environment list, the pointer of environment list, home, the path, so many variables are there. PWD, the address, the environment list. Sorry, not the command, it is the environment variables. What about this P is, this is clear, right? This file name, the last two. These are the main differences about this execute function. This execute VE, it is a system call. It is a system call in so many operating system. It's a system call. One example you can see how the execute function will be used. Like it is like this. If you have not sent the attendance, please send. See this PID, if the PID fork, if it is less than 0 means fork error. If PID equals 0, then 1 minute. If PID is 0 means child process is executing. See, execute LE. Execute LE means list with that environment list. See the environment list, user and path. We are just sending two environment variables, environment character array. In that two environment variable, name equals value. That is the syntax. This environment list, it is required for the new program. That program is echo all. The child process was executing. It is executing. Now it has to execute the other program, echo all. Now this echo all, it is in this location, home. Inside that there is a folder called SAR. Inside that there is a directory called bin. Inside that there is a file. And these are the arguments. After that, the arguments. The last one will be the environment list. Sorry, environment list. If it is less than 0, execute the error in case of the execution. If it doesn't returns anything means, if it returns less than 0 means there is a problem, or else it is successful execution. See LP, here you are directly giving the file name. Here directly we are giving the file name, but in case of This is the difference between LE and this LP. See, in case you have to give the complete path. In case of LP or VP, function execute LP or execute VP, directly you have to give the file name. In that environment itself, it is going to search. Next, this is all about the execute function. The next topic is this topic, the changing user IDs and group IDs, it belongs to the fourth module, and now we are going to start the fourth module. From here, the fourth module starts changing user IDs and group IDs. See, you have seen the IDs, process ID, PID, parent ID, all those things. See, one more IDs you are seeing, some user ID and group IDs. Why these things are required? The first question is, why these IDs are required? See, privileges, there will be so many hardware resources. There will be so many hardware resources in your computer. So many millions of process is going to be running in the background. Lightweight process, the threads or all those things. In order to give the privileges to some process, in order to remove the privileges for the other process, we are going to take some unique ID for the with a process. For that process, what we are going to do is we are going to set some user ID. This user ID, when it is been set, user ID is nothing but some number. User ID is, it is one number. Even you can check in the Unix operating system, in the login you can check using the command called ID. If you just enter ID there, you will see the number. User ID equals some 1000, group ID, GED equals 1000, groups equals 1000. Means some number is being given to that group. To that number, there will be a privileges. You can assign the privileges or you can remove the privileges with that ID. Every user, whenever he is going to log in, whenever the user is going to log in, he will be given some user ID and he will be added to one group ID for every user. If you check for the root, the numbers will be 0. For all the others, for all other users, you will have some number. How to set the user ID and how to set the group ID? You have some number, you want to assign the user ID and group ID. This is the function, int set user ID UID and int set group ID. This is a function you can use to set the IDs. In this, remember, whenever you set the user ID, a single function, see this function, whenever you set this user ID, that value which you are going to pass, that number, it is stored in 3 places. It is stored in 3 places. What are the names of that places are real user ID, effective user ID, and saved set user ID. These are the 3 names. At 3 places, these values are being copied. See, at 3 places, these values will be there. The 3 places are real user ID, effective user ID, and save set user ID. Remember, if that process has super user privilege, then that set user ID function will set these 3 values to UID. The process which is going to execute this function, ಯಾವ process ಈ function execute ಮಾಡುತ್ತಲ್ಲ, ಈ 3 values user ID ಏನು 5000 2000 number pass ಮಾಡಿತ್ತಲ್ಲ ಅದಕ್ಕೆ set ಆಗುತ್ತೆ. It will set those values to these 3 numbers. It is going to copy. If he doesn't have the super user privileges, the user ID equals either the real user ID or save set user ID. It is going to copy to either one of them, but it will set the effective user ID to UID. It doesn't have a super user privileges. If it doesn't, neither of the first condition is true, the error number will be set. That is a different case. The error number will be set. Super user privileges, all the three values will be set. If it doesn't have a super user privileges, effective user ID will be set and real user ID will be set. This is a table which says about the real, what will be the real user ID, what will be the effective user ID and saved set user ID. Whenever you execute function will be called what are the whether the values that gets changed or not. Whenever you execute the whenever you use the execute function, now the process is running the some other program, a new program. In that case, the values were set for the previous program. Whether they are gets changed, no. See here, they are unchanged. It will be copied from effective set user IDs. See why we are storing at a different places is because we have to come back once again after some time. That is why we are going to keep the backup. There are two functions, set RUID, set REGID. What is the meaning of this is you are going to swap the user IDs and the group IDs, the effective user ID and the real user ID. If you want to swap, you are going to use this. In case of user ID, for group ID, in order to swap between these two values, you can use this. We are going to discuss all these things in detail in the next class. These are IDs, the user and group IDs. Now we have started the fourth module. Thank you for today joining, and we'll meet in the tomorrow's class with this user IDs and group IDs. Thank you everyone. If you have sent the attendance, you can exit.